Alright, Chapter 9 review video. I wouldn't watch this whole video. I wouldn't start at the beginning, just watch it to the end. I would actually look at the answers first and then kind of fast forward to the parts on the questions that you need. Otherwise, I got a feeling this is going to be kind of a long video. Alright, so starting with number 1, find the area of each. The biggest thing is knowing the area of formulas. So the area for this is base times height, which 9 is the base and 6 is the height. So this would be 54, and then whenever you're dealing with area, it's always square units, so square feet. Number 2 is a triangle. Area for a triangle is 1/2 base times height. Be careful here. The base is right down here, so 1/2, that's 6. And the height is actually perpendicular to the base, so this is going to represent the height, so 6.3. And basically got to crank these out, put them in the calculator. 3 times 6.3, I believe that's 18.9. Let me just double check. 3 times 6.3. Yep, 18.9 kilometers squared. Alright, moving on down. Let's knock out 3 and 4. See if I can get a few more on the screen at a time. So 3 and 4, so this shape right here is a parallelogram. Parallelogram, I got 2 bases. Area of a parallelogram is just base times height. It's just like a rectangle. So my base is 12, and kind of similar to the triangle in the last one, the height is 10. The height is defined as the distance between the 2 bases. So that would come out to be 120 square feet. Alright, number 4 is a trapezoid. So you could just use the formula for the area of a trapezoid. The problem is you have 2 bases. You have 2 and you have 8. We typically call one base number 1 and one base number 2. Since you have 2 bases, one base is too small, the other base is too big. So the formula for the area of a trapezoid is the average base times the height. So it's very similar to all the other ones, base times height, but it's the average base. So I have to average these 2 numbers, which basically means I have to add them up and then divide by 2. So 10 divided by 2, that would be 5, and then the height is 4. So 5 times 4 is 20 kilometers squared. So still base times height, just 8's too big, or 8's too big, 2's too small. So you need to find kind of the average base, which is also known as the median. Right there. The median is 5, or the average is 5. Number 5, this just looks like a triangle. So I'm going to use the 1/2 base times height. There's a lot of numbers here. The key thing that you always need to know is that the base and the height have to be perpendicular to each other. They always have to make a 90-degree angle. So this 90-degree angle will touch the base and the height. So my base is 9, half of 9, and my height is coming down here at 5.2. So let's do that. 0.5 times 9 times 5.2, 23.4. And this is yards squared. Now I'm just going to tell you right up front, I don't have an answer key while I'm doing this. I'm just rocking it out as quickly as I can. So chances are I'm going to make a mistake, so hopefully you guys will catch that mistake and we can talk about it before the test. So don't take this all as gospel. This is just me doing a lot of it in my head and some on the calculator, and definitely can make a mistake. Now this triangle over here, normally I would say that this is the base, which it could be. In the triangle you have 3 choices for the base, any of the 3 sides. The problem is I don't have a height coming down, so I cannot use 10 as the base. So on this particular problem, I need to find where the height is, which here is the height. So that forces me to use this as the base. So here's my base, here's my height, and I'm just going to rock out 1/2 base times height. And I do that, and that's what? 0.5 times 9 times 8.3. Getting 37.35, and these are meters squared. Up above, I didn't really point this out, but I'm going to just say this now. For this trapezoid problem, the formula is actually base 1 plus base 2 chopped in half times the height. I kind of did that right here, but I didn't really write the formula down for it. So that's the area of a trapezoid. All right, let's scroll on down. Now we're moving into the circles. Find the area of each. Be prepared to write your answer either with pi or with decimals. So first thing you need to know is area of a circle is pi r squared. Sometimes I like to reverse the letters and do r squared pi. I'll show you why here in a second. So a radius, remember, is halfway across a circle. So this is my r. So 2.5 squared times pi. So 2.5 squared is 6.25 pi. Now, they may leave that as the answer. You know, standardized testing, a lot of times they'll leave pi in the answer. If they want a decimal, now I just actually have to multiply it out. I'm going to use the pi key. You could also use 3.14. And I get about or approximately 19.63. All right, roughly. Next one, I'm going to use the same formula. I'm going to use the r squared pi or pi r squared. Problem is this is not r, this is d. So I need to cut d in half. The radius is half of that. So the radius would be 8. So 8 squared pi or 64 pi. That's the exact answer. 64 pi decimal wise is about 201 point, and I think it just says go to the nearest tenth. So I guess I'll stop here, 201.1. So I guess on this other one over here, I probably should have just called that 19.6 if I'm following directions. All right, moving right down, number 9. Moving pretty quick on this first section. So number 9, I need the formula. So for circumference, circumference is the distance across multiplied by pi. Or if you prefer, you could use 2 radiuses times pi. Either one, because 2 radiuses and 1 diameter are the same. So looking at this problem, this is d. So for circumference, it's just 13.6 pi. If I want to multiply that out, 13.6 pi, it would be 42.7. And on circumference, you don't square the units, it's just the length. So these are just miles. Now, since this one is r, I'm going to use the r equation, and I'm going to use 2 times r times pi. So that's 20.6 pi. And if I crank that out calculator wise, I get 64.7, and it looks like these are meters. So those are circumference there. All right, moving on down. Now we get into a few more of the kind of the word type of problems. See if I can get 4 on a screen. That would kind of be nice. Maybe. All right, so number 11, in a parallelogram, AB is 12, so let's label that. AB is 12, which automatically I know parallelogram has opposite sides equal, so the other one's 12. I do not know how long AD is, and I do not know how long that side is, but the big clue here is the perimeter is 60. So all of those sides add up to 60. So you could formally do it with algebra if you wanted to. I add up all those 4 sides and I would get 2x plus 24. You know, I didn't show it, but it's really x plus 12 plus x plus 12. Just add up all 4 sides and it'll turn into this. Has to equal 60, and then I could just solve for it. 2x equals 36, and x has to be 18. Now, a lot of you probably didn't have to formally do it with algebra. You just add the 12 and 12, subtract it from 60, and divide by 2. That will also work. I'm going to jump over here to 16, just because it's easier for me scrolling. So, or actually, I better do it in order. If people are jumping through the video, they might want to do it in order here. So, number 12 says, what is the perimeter of a rectangle if it has a length of 18 and a width of 7? So this one shouldn't be too bad. Let's draw the rectangle first. Draw a rectangle. Length of 18, width of 7. Well, on a rectangle, I know that opposite sides are equal. So perimeters, just add those guys up. That'd be 25 and 25. Perimeter would be 50 inches. Add up all four sides. Number 13, what is the perimeter? So we have a kind of irregular shaped piece here. Now we do have some missing dimensions. So let's put what I have. I have 7. I have 3. I don't know, but I have a 4. And then I have 12. So far I have 4 of the sides, but my problem is I'm missing this side and I'm missing this side. So I need to get those two sides before I can finish. So to get this vertical line over here, I'm going to go to the other side of the drawing and I'm going to look at, I have this 3 and I have this 4, which together makes 7. So that will give me the length of this side. And then to get this little piece right here, I'm going to use the horizontal pieces. I have 7, and then I have 12 as the whole thing. So I'm going to subtract 12 minus 7, and that's going to give me 5. So now that 7 plus 5 equals 12. And so I add the 5 in, and now I should be able to get the perimeter. That's 10, 14, 26, 33. I believe that is 38 feet for number 13. All right, keep on going. Number 14, a rhombus. So this says, what is the area? I kind of zoom right to the keywords. What is the area? So I know what formula I'm having to do. So area of a rhombus is 1/2 diagonal number 1 times diagonal number 2. This works for both rhombus and it also works for kite. It's the same formula for both areas. So AB is 10. So that makes it kind of nice. You know, looking at my area formula, I have 1/2 times 10. Now I need to get the other diagonal. So let me draw this other diagonal in here. There's the other diagonal. And it says CD is 6. Alright, well that makes it nice and easy. CD was 6. AB was 10. This one's pretty straightforward. I just stick 6 in here. So 1/2, 10 times 6, that comes out to be 30. So the area is 30 square inches. So 1/2 diagonal times diagonal. Now, if you were to get in a pinch, you could also use triangles. You know, if AB is 10, half of that would be 5. And if C to D is 6, half of that would be 3. And you could do area of the triangle. You know, so I could find this particular triangle is 1/2 base times height, or 1/2 of 3 times 5. That's 7.5. And you could just add up all 4 triangles because they're congruent. And you would also come up with 30 that way. It's longer. I would prefer you to use the area formula, but it could be done without it. Moving right on down, number 15 says the diagonal of a rectangular garden is 13 and one side is 5. So rectangular garden, diagonal is 13 and one side is 5. What is the area? So area of a rectangle is just base times height. The problem is, I know the height. The height is 5, but I don't know what the base is. So I got to find this base down here. I'm going to just call it X because sometimes B's looks like 6's and gets confusing. So since it's a rectangle, I do have a right triangle. And whenever you know 2 out of 3 sides on a right triangle, I can use Pythagorean Theorem. Now I heard some kids saying, hey, you know, let's use trig. Unfortunately, I don't know these angles, and I have to have one of those angles to use trig, so trig's not available here. But remember, Pythagorean Theorem, leg squared plus leg squared equals the hypotenuse squared. So I crank that out, and I get x squared plus 25 is $1.69, which, subtracting the 25 from both sides, I get x squared is 144. And take the square root, and I get x equals 12. Now, some of you probably recognized your Pythagorean triple earlier, and you didn't have to go through all that, and you could have just got 12 right out of the gate. So remember, there are some Pythagorean triples that are worth memorizing. They are 3, 4, 5, his big brother, 6, 8, 10, and then 5, 12, 13. These are the big three. They show up a lot. There's a couple other random ones that that might be worth knowing, that I just know because I've done a lot on the ACT and they used to love these. So Pythagorean triples. Okay, moving to the top of the other side, the other column, number 16. The perimeter of a square is 32. What is the area? Again, I cannot emphasize enough, draw the doggone picture. See too many people asking me questions on how to do something, and they haven't even drawn the shape in question. So I have a square that the perimeter is 32. Now the nice thing about a square is all four sides are equal. So if all four sides add up to 32, if I divide 32 by 4, that will tell me how much each side is. And now the area of a square is just like a rectangle. Area is base times height, or 8 times 8. So that answer is 64 square centimeters. So not too bad. All right, cruising on down, number 17. Parallelogram with dimensions in inches. What is the area in square inches? So this one shouldn't be too bad. Again, know how to find the area of a parallelogram. It's pretty easy. It's exact same as a rectangle. It's just base times height. Well, here's the base. So I got to add 8 plus 14 together. That's 22 is the base. And then the height is 6. So 22 times 6, that's 120, plus 12, that's 132. And we're just talking inches squared because it's an area. All right, moving on down. Number 18, what is the area of the figure below? So when you see these, be sure if you know whether it's area or whether it's perimeter. So area, you have two ways to chop it. I'm going to chop it vertically. You could have chopped it horizontally. And basically I'm going to find the two separate areas and I'm going to add them together. So I'm going to do the blue area, and then I'm going to separately do the red area and rock those out. Now I'm using base times height for both of these because they're rectangles or squares. Actually rectangles. Now the key is getting my numbers correct. So on this one over here, my base is 5 and my height is 6. So that has an area of 30. The red one's a little trickier. The red, I know the height is 4, but I do not know the length just yet. So I kind of have to figure out how long this red piece is right here. But I used a clue. Since it's 12 all the way across, since that whole thing is 12, and this is 5, subtracting those numbers mean it's got to be 7. This little piece has to be 7. So 4 times 7 is 28. Add those together for a grand total of 58 square meters. All right. Moving on down, number 19. In the figure below, FGH is a square and QR and S are midpoints. So let me just put a few pieces of information right there. If it's a square, I know I have these 90s in here. Q, R, S, and T are the midpoints. So this equals this. All these. So we have 4 triangles here that are all the same. G to H is 10. So G to H is 10, which means these guys are 5. So I have 5s all the way around. and it says, what is the area of QRST? So what they're really wanting me to do is they're wanting me to find the area of this red square. Now there's a couple different ways to do it. I could figure out how long this side is, and I could just find x and then multiply x times x and get my answer. And this wouldn't be too bad if you want to do it this way. Basically, this is a special right triangle. You know, these two, it's isosceles, and it's got a 90 here. So that's a special right. And on the special right triangle rules from last chapter, if the legs are 5 and 5, then the hypotenuse is 5 radical 2, which makes this hypotenuse 5 radical 2. So when I do x times x, I'd have 5 radical 2 times 5 radical 2. And you can multiply the whole numbers, and then you multiply the radicals. Square root of 2 times the square root of 2 is the square root of 4, or just 2. And you'll get a final answer of 50. Now that's a little tougher. I want to kind of show you an easier way that if you don't need to know special right triangles, and it's quite a bit easier. So once you have your 5 stuff, kind of think about it this way. Connect these lines, and look what I have. I now have 4 red triangles, and I now have 4 blue triangles. So I'm going to argue that those 4 triangles should be half of the entire square. So if you look at this whole square, it's just 10 by 10. 10 by 10 square. So the big square is 100, which would mean the little square inside of it is going to be 50, because it is exactly half of that picture. 4 triangles inside, 4 triangles outside. So that was a way to do it without special right triangles. I actually didn't come up with that myself. A student showed me that. I thought it was kind of cool. Number 20, if a square has an area of 64, so let's draw it. And I have an area of 64. What is the largest circle that can go inside the square? So let me get that 64 out of there. Let's put a circle inside. Not the best circle, but oh well. So I need to find the area of the largest circle. So area of a circle is pi r squared, or r squared pi. So here's my dilemma. If I know the area of the square is 64, I basically ask myself, what times itself gives me 64? And that answer is 8 times 8 will give me an area of 64. Now I can find the radius. The radius of this circle is half of that square. So the largest circle that can fit in there is pi 4 squared, or 16 pi, which 16 pi comes out to be roughly 50.3. And we're talking it just said square units, so I'm just going to write units squared. All right, number 21, moving right along. Area of a trapezoid below is 90. Now, right away, I want to use a fact that I pointed out earlier. Area of a trapezoid is simply the average base times the height. And they're telling me it equals 90. So, I know what the height is. The height of this trapezoid is 6. So basically, I have the average base times 6 equals 90, which means the average base must be 90 divided by 6. The average base must be 15. So if the average base in here, the middle base, is 15, then it looks like the other base, I went up by 2, so I got to go up by 2 again. The other one must be 17. And if you want to double check it using the formula, base 1 plus base 2 chopped in half times the height, I think you will find that it does check out to be 90. So 17, I believe, is the correct answer for that problem. All right, moving on down, number 22. Got another trapezoid. Got to put some labels on here. AC is 10. B to D is 14. Perimeter is 58. Find the area. Perimeter is 58. Well, let's think about this. Let me use this clue. The perimeter is 58. If the perimeter is 58, let's just call this piece up here X, and let's call this the bottom piece down here Y. All right. So that means that when I add up my sides, I have 24 plus X plus Y equals 58. So subtracting 24 from both sides, I know that X plus Y actually comes out to be 34. All right, X plus Y is 34. Now, I'm going to use this fact to get my area, because if you think about the formula, you remember this is base 1, this is base 2. The formula says base 1 plus base 2 chopped in half times the height will give me the area. Well, look what I have. I have base 1 plus base 2. Base 1 plus base 2, I didn't know the pieces individually, but I know together they had to add up to 34. So basically 34 divided by 2 times 8. So what's 17 times 8 is 136. That was a tough problem. That problem's no joke. That was a rough one. Made you think a little bit. Number 23, equilateral, find the area. All right. Well, area of a triangle is 1/2 base times height. And I do have the base. Problem is, I do not know what the height is. So here's the height. We're going to call it H. Now, the nice thing is, since it's an equilateral triangle, I know that everything is 60 degrees. And I know this top part would be 30 because the 60 gets chopped in half. And another nice thing is, if this whole thing is 8, this little leg over here is 4. So now, if you focus on just this triangle right here, I'm going to redraw it, putting only the important pieces. If you're 4, and you're, I don't know, and you're 60 degrees and you're 30 degrees, you have two ways you can solve this. One is using trigonometry. I'm going to use the special right triangle rules, because this is the baby side. The middle side is going to simply be the baby times the square root of 3. Now, you also could have stood here and used tangent, or stood here and used tangent to find it, but I'm going to try to work smarter and not harder and avoid the trig if I can. So 1/2 of 8 is 4. 4 times 4, that'd be 16 radical 3, which comes out to be 27.7. All right. Now moving on up to number 24. Oh, the length of a rectangle is 3 times its width. So again, draw the doggone rectangle. And the length is 3 times the width, and the area is 75. Now, you could just try the guess and check method if you want. Okay, you could just guess, or you could use algebra. Alright, so back to number 24. Class started, so I had to get things rolling. If you hear a little background noise, they're working on their review. I may have to yell at them here in a second, but bear with me. So, the guess method. I kind of like the guess method because you could do length times width. You know that it has to come out to be 75 because the area is 75. And now let's just start picking numbers to where the length is 3 times bigger than the width. So just pick some number, I don't know. Maybe make the width 3 and make the length 9. So now I've guaranteed that the length is 3 times bigger than the width. But that's too small. It only comes out to be 27. So that can't work. So let's try 5. Go a little bigger. if the length is 3 times bigger than the width, that would be 15. If I multiply those two, boom, right there on the second guess, I got it. I found the length, I found the width, I'm done. Now, if you wanted to do it using algebra, you could say you have the width and the length is 3 times bigger than the width. And now I solve the equation. Length times width equals 75. 3w squared is 75. Divide both sides by 3. 25. And then take the square root of both sides. And you'll get w equals 5. And then once you plug that in over here, you'll get 15. And you could have did it with algebra. So use whatever way you want. For a lot of you guys that aren't as algebra savvy, even me on an SAT, I'd probably use a guess and check because I think I can get there faster than doing the algebra. Alright, moving right on down, number 25, find the area of a parallelogram. So first thing that jumps into my mind is, what the heck is the area of a parallelogram? Well, that one's pretty easy. It's just base times height. So here's the base, and here is the height. Alright, well, we got to find out what these numbers are. So thinking about the coordinate grid, this is the x number. So that means I cross at 2. This is the x number, and that's going to cross at 10. So the distance from 2 to 10, that means this base is worth 8. So I know my base is 8. Now when I do the height's controlled by y values. So I basically got to figure out how far it is from here to here. Well, the y value is at 3, and this y value is at 6. So the distance between 3 and 6, that has a height of 3. And now we can get our answer. Base times height is 24. So the area of that parallelogram there is 24. Move on down. Ooh, now we're getting into some polygons. So find the following. We need to get the sum of the inside, each inside, and each outside. So hopefully by now some of you guys have these memorized. I'm going to do it as if we don't have it memorized. I always start on the outside. I like to do 360 divided by however many sides there are. So for this problem it would be 360 divided by 1, 2, 3, 4, 5, 7, 8. So 360 divided by 8 is 45 degrees. So this is the exterior angle. Okay. Now the interior, I do 180 minus the outside, and that gives me the interior. And now if you want the sum of the interior, it's 135 multiplied by 8. So that's 800, 240, that's 1040, 1080. 1080 degrees. So this is what's referred to as the sum of the insides. Now, one thing you should always know, 360 is always the sum of the outside, the sum of the exterior. Alright, so this next one's a weird shape. I don't have it memorized. It's got 1, 2, 3, 4, 5, 6, 7 sides. It's kind of funky. Doesn't come up too much in real life, so I don't have it memorized. So I'm going to do 360 divided by 7. That's going to be a weird decimal. So I'm going to cheat, grab my calculator. Michael's yelling at me that it's what? 51.4. Hope he's telling me the truth. So that's the exterior. Subtract from 180. That'll give me 128.6 for the interior. And then for the sum, I got to do 128.6 multiplied by 7. If you want to, I don't usually do it this way, but there is a formula for the sum of the interior that is the number of sides take away 2 times 180. So I also could have used that to get this answer if you want to start on the inside. So 7 minus 2 times 180, or 5, which that looks like 900 degrees. So there's 900 degrees should be the answer for the sum of the inside. So you can start inside and go out, or you can start outside and go in. Alright, moving on down. This is where things start to get a little bit rougher, a little bit tougher here. So, trying to find the area of a polygon. Area of a polygon. We spent a lot of time on this. Formula is 1/2 apothem times perimeter. Alright? Or 1/2 AP for short. Well, the one on the left is going to be pretty easy. It's going to be not too bad. Alright, I had to get after these knuckleheads. So, 0.5. Now, the apothem, A, is the distance from the center to the edge. That's what we're calling A. So there's my 12. And perimeter is all the way around. So for this shape, my perimeter is going to be 13.9 multiplied by 6 sides, because we had 6 sides here. So I crank that out, 13.9 times 6, and I get 83.4. So that's an easy one where I give you both the apothem and I give you a side length, and that one's not too bad. No, wait a minute. I didn't finish that problem. All I did was the perimeter. So the perimeter is 83.4. So the final answer is all of that. So I had to do 0.5 times 12 times 83.4, 500.4. Alright, now we get into the rough one. This one's kind of tough because all I'm giving you is a side. So I start off with my generic formula. I need 1/2, I need A, and I need P. And I got neither one of those numbers. So P shouldn't be too bad though. For perimeter, since this side's 14 and I have 6 of these sides, that's going to be 84. So my big challenge for this problem is how can we get the area, or not the area, the apothem. So I'm going to draw it in. I'm going to draw the apothem in. I'm going to call it A, and I'm going to draw a radius here. And since it's 14 for each side, that means this little piece is 7. Now, in order for me to do trig, or in order for me to do special right triangle stuff, I need to know an angle in here. I need to know what these angles are. And for a hexagon, it's 120, which is going to hook me up with this little 60 degrees right here. So now I'm going to kind of jump out of this shape, and I'm going to just solve this triangle. And a lot of people right here prefer to use trig. You know, there's quite a few people that would stand here. They would call this opposite. They would call this adjacent. And they would use tangent. And they would say the tangent of 60 degrees is opposite over adjacent. When A is high, you multiply. So 7 times the tangent of 60 degrees is 7 tan 60. Boom. Let me just check my mode. I'm using a graphing calculator and I'm in radian mode, so I need to change that to degree. So 7 tan 60, 12.12. So now I come back, I put that 12.12 in, and I should be able to get the final answer. 0.5 times 12.12 times 84. And 509.04, And if you have trouble hearing this, you can just yell at my fifth block, because they're the knuckleheads back here acting crazy. You also could have used special right triangles. You also could have used this baby and went up here and just did 7 radical 3, and that would have been a lot faster, and you could have skipped the trig if you remember your special right triangle stuff. Alright, moving on down, looks like we got a couple left, so let's see what we got here. Let's do 28. This problem is similar to what we did on our homework a couple days ago. So, area of the shaded region. Alright, so area of a shaded region. Typically, you're going to have to do addition or subtraction. If you run into one like this on the test, if you could just start off by giving me the basic shapes and showing me who you're going to add or subtract. For like this problem, if I want the shaded region, I'm basically going to have to find the area of the square, and then I'm going to subtract the area of the circle. So I need to know those two formulas. So the square, remember, is base times height. A circle is pi r squared. So I have a base and I have a height. So base times height, that's 100. And now I need the radius. Well, the radius is halfway across this square. So half of 10 should be 5. So this should be pi times 5 squared. This might be the exact same one that was on our homework. So I finished that. 100 minus 25 pi. That would be an exact answer maybe on an SAT or ACT, but I'm going to go ahead and get a decimal for it. So 100 minus 25 pi. And you get 21.46. That one was on the homework. I remember that one. Alright, looks like we got a little spinner problem here for number 29. So find the probability that some stuff's going to happen. So let's check out this circle. So probability, remember, is how something, ways you can win over all the total possibilities. So what's the chance I'm going to land on A? Well, A, to win, I got to land right there. So it looks like 45 different degrees I can win out of a possible 360. So I could divide those two numbers out. I could also reduce that, you know, if I wanted to. I know that that's 1/9, but I'm going to go ahead and divide it out. 45 divided by 360. And this is 0.125 or 12.5% chance of winning. So not very good. What's the chance that it's going to land on E or C? Well, E or C means I'll win here or I'll win here. So my winning area is 45 and the 120. This is where I win out of the total. So that's 165 out of 360. And let's divide those out. That is 0.458, a bunch of 3's. So move it 2 places. So that's about 45.8%. So you're still going to lose more than you're going to win. You would not want to bet on that game. The last one. I can win if I do not land on D. Well, not landing on D would mean I win on all this stuff. Now, I could add up all those numbers, but that's a lot of work. I think it's easier to just do 360, take away 60. So it looks like I will win 300 degrees out of the 360. So 300 divided by 360, 0.833, which is about 83.3%. So I would definitely want to bet on that game. I will win that game quite a bit. Alright, so there's some probability with a spinner. Let's zoom over to the last couple. We need to find the shaded area of this cross. I don't think this one's too bad. Let's see if we can do this. Find the shaded area. I might just break these guys up into squares or rectangles. So it looks like this rectangle is 4 by 5, so that's 20. This rectangle over here is 4 by 5, so that's 20. This one over here is 4 by 5, so that's 20. This bottom one is 4 by 5, so that's 20. And this middle one's where you gotta be careful. The middle one is only 4 by 4, so he's 16. I bet a lot of people are going to put 20 on that one, if I had to guess. So when I add up all those, grand total is 96. So that one was kind of tricky. That center square might get you, so be careful. Moving down the last one. This is probability. What is the chance that a random point inside the rectangle lands in the triangle? Well, so remember, it's target area over total area, and the total area is 60 by 30. So 60 times 30, that's 1800. The target area is this triangle that is 15. Oh, and this kind of sucks because I don't know the base. If I knew the base, I could just do 1/2 base times 15, but I got to work for it a little bit. So this triangle, I'm going to have to use Pythagorean Theorem. So I have x, or no, check that. Oh, check that again. So on my triangle over here, I have 15, I have I don't know, and I have 25. So x squared plus 15 squared equals 25 squared. And you would keep going on that. I kind of see that this is the big brother of 3, 4, 5. 3, 4, 5. This is like the 5th biggest brother. So I'm going to cheat and zoom ahead. I know the answer is 20. Now you could have finished out the Pythagorean theorem, but I'm going to just zoom forward. So my area of my triangle is 1/2 base times height. So that's 150. And let's divide those out. 150 out of 1800 is 0.083333. So that's about 8.3%. So not a very good chance you're going to land in that triangle. Alright, what's the chance that I do not land in the triangle or the rectangle? The white rectangular triangle. So basically, I could replace this with what's the chance I'm going to land in the shaded region. So that's my target area. Here's my total. I can work kind of smart on this one. I've already did the total right up here above. So I'm going to cheat and pull that 1800 over. Alright, so shaded region. Here's where the money's made. So shaded region, I'm going to do big rectangle, take away little rectangle, take away triangle. And that should equal the shaded area. And I have some of these numbers already. I have the big triangle. We calculated the little triangle. That's $1.50. And luckily this one's not too hard. Base times height, that's 75. So remember this one over here was 150. So 1800 minus 75 minus $1.50. 1800 minus 75 minus 150 is 1575. That is the shaded region. So divided by 1800, I get 0.875, or you have an 87.5% chance of landing in the shaded area. Whew! This is probably the longest video I've ever made in a hot, stuffy room. So I believe that's it. Hopefully it gets you ready for the test. See you.